네, 안녕하십니까? 저는 스웨덴 컨트리데이의 오전 프로그램인 스웨덴 수소 생산 및 연료 전지 정책 기술 세미나의 사회를 맡은 주한 스웨덴 무역투자대표부 류연주입니다. 이 자리에 참석해주신 모든 분들께 주최 측을 대신해 진심으로 감사드립니다. 내빈 여러분들께 의미 있는 자리가 될 수 있도록 많은 준비하였으니 기대 부탁드립니다. 오늘 스웨덴 컨트리데이는 총 2개의 세션으로 나눠져 있습니다. 지금 진행되는 세미나에서는 수소 생산 그리고 연료 전지에 적용될 수 있는 기술들을 소개하고 스웨덴의 수소 생태계와 정책 동향 그리고 민관학 협력 사업의 사례들을 발표할 예정입니다. 2시부터 시작될 오후 세션에서는 한국과 스웨덴, 정부와 산업계가 수소 생산과 활용을 주제로 양국 간의 시너지를 활용해 에너지의 전환을 촉진하고 국가 기후 목표를 달성하기 위한 노력과 각자의 역할에 대해서 논의할 예정입니다. 질문은 모든 발표 세션이 마무리된 후 질의응답 시간에 자유롭게 질의해 주시면 되시겠습니다. 그럼 세미나의 세부적인 내용에 앞서서 사라 모티그 스웨덴 산업통상에너지 차관께서 바쁘신 가운데 비디오로 개회사 및 환영사를 보내주셨습니다. 따뜻한 박수로 환영해 주시기 바랍니다.
Dear guests, thank you for giving me the opportunity to speak to you today. In Sweden, we have a parliamentary decision to be the first climate-neutral welfare state by 2045. I am very proud of how industries in Sweden have taken on the challenge of climate transition. Under the initiative Fossil-Free Sweden, industry sectors draw up their own roadmaps on how to be fossil-free while increasing their competitiveness. To date, over 20 sectors have committed to a roadmap, including industrial sectors such as steel, cement, forest, and mining and minerals. Sweden believes that hydrogen is one of several technologies that need to be developed in order to achieve climate neutrality. We see opportunities for hydrogen in industrial use, especially in the transportation sector and for energy storage. We are already seeing the results of the efforts in Sweden. The steelmaker SSAB has now used the hybrid process based on hydrogen and produced the world's first fossil-free steel and delivered it to the Volvo Car Group. Other actors in this market, as H2 Green Steel, are also moving forward. The hydrogen is only as clean as the energy that is used to produce it. We believe hydrogen should be produced with electrolysis from fossil-free electricity. Furthermore, hydrogen and its infrastructure should be developed around industrial clusters where no cheaper alternatives for reaching climate neutrality can be found, and where the market is willing to pay for the unique properties of hydrogen. The production, distribution, and use of hydrogen should grow at a pace that enables cost efficiency and industrial co-financing. In order for this to be achieved, industries in various fields need to come together and collaborate, public and private sector, and internationally. You have an ambitious strategy to develop the hydrogen economy in South Korea. And you have come a long way in several areas. We look forward to continued contact on this important topic. Finally, I wish you all a very exciting seminar today. Thank you for your attention.
네, 감사합니다. 다음 순서로는 스웨덴 무역투자대표부 안나 리베리 글로벌 수소 부문장께서 스웨덴 수소 에코시스템 관련해 비디오로 발표해 주시겠습니다.
Good day. or a good early morning from Sweden to all you dignitaries, global partners, colleagues, and hydrogen friends. I am Anna Liberg, and I lead the work at Business Sweden to create global partnerships within the hydrogen value chain. I will speak about how Sweden and the Nordics are building up the hydrogen ecosystem to achieve green transition and value creation, and how we welcome Korean partnerships in this endeavor. Firstly, I would like to take a look on what we call the hydrogen value chain. And that takes us from sourcing of energy and electricity, converting that into hydrogen or hydrogen derivate, some kind of transport or distribution, or whether the hydrogen is produced on site, and all the way to the use and application areas, which could be in industry as feedstock or heat, in transport, or in the heating and power sector. And in the Nordics and Sweden, we would like to be part of all the steps to also go all the way to what we call the top of the hydrogen value chain, which is to the right of the picture here, to also be part of the use and application side, because that is where we see that we have the maximum green transition effect, and where we also create the highest number of job opportunities, as well as export or import value. And we see a great potential with partnership with Korea and Korean companies to put both Sweden and Korea at top of the hydrogen value chain. I would just like to zoom out of Sweden and put Sweden into the context of the Nordics, our neighbors, because we share a few common important factors when it comes to hydrogen. We are a region that are fortunate to be very rich on being able to produce electricity, and that is fossil-free electricity and to a very large part renewable electricity. An interesting data point is that Sweden is actually EU's largest net exporter of electricity, and that is fossil-free electricity. We also have abundant amounts of water, fresh water, and space. We have a very strong industrial heritage in all the different application areas where hydrogen is used. But I would especially like to highlight that we are all globally top ranked within innovation and sustainability rankings, which we believe is also crucial when it comes to pushing forward in development of application of hydrogen. I spoke about the value chain, but the value chain is nothing without having the right actors driving it. And you see here the map we have done from sourcing in the conversion step into hydrogen, transport distribution, and the use and application areas, who are all the main actors within the Nordics. And you recognize many leading companies here, for example, Alfa Laval, Cell Impact, Impact Coating, and Kraft Powercon. But there are also a few white spots here where we would need Korean partnership to speed up the development. That could be suppliers of electrolyzers, companies with know-how and technology within fuel cell or adjacent technologies, but also in the application areas of transport, of actually getting hydrogen as a driver in transport on the road or in the air or by ship, but also on the industrial side. Sweden, we believe that we have in the last year put ourselves on the global map by lighthouse projects within production of green steel enabled by hydrogen. And last week, we actually marked a milestone in the Swedish steel history by having the company Ovako being the first company in the world to, what we believe, produce fossil-free steel based on hydrogen. But it doesn't stop at steel. We have projects happening in the region in the area of green cement, green chemical, textiles, etc. And you also see that there is a plan to have a hydrogen pipeline backbone connecting us to central and continental EU. Then looking out into global markets, and besides our closest market, which is obviously the EU, it is obvious that Korea stands out as a very interesting partner, both from an export-import perspective as well as investments perspective. And that goes both looking at hydrogen as such and derivatives of hydrogen, but also key enabling technology, as I have mentioned. And an area that I would highlight especially is looking at the importance of creating a dedicated premium market for green products based on hydrogen. And I think one key example is looking at what is now happening within steel, where we can see now that it is possible to get a premium price of green steel of about 20%. So even if the cost of steel, green steel might be higher, you get an even higher sales premium price. But looking on the cost of steel going into the end product, such as a car or a windmill, it's a very small part of the total cost, but the end customer is ready to pay a premium. So this is a great example of how a premium market for green products can be created. And we would be very keen to explore how we could develop that market together with Korean actors. To round off, I would like to invite you all to engage in partnerships and more hydrogen-driven business with Sweden and Swedish actors. And just a recall here on what Sweden would like to bring to that partnership. And I start from the bottom here. Sweden, we have a very stable and beneficial business climate and a collaborative culture, which is key, we believe. We are leaders within sustainability and innovation. We have an ecosystem of actors within the industry and mobility, which already are global brand names and are about to create first in the world highlight and lighthouse projects. Besides hydrogen, we also have large access to biogenic carbon based on the large forest reserves in the Nordics. Looking at hydrogen itself, we have in the Nordics an offer of both green hydrogen, but also blue hydrogen together with our neighbors in Norway. And of course, a key factor is that we have large amount of fossil-free and green energy. So I'd like to thank you very much for listening in and wishing you a very beneficial seminar and fair. And I hope that this will be the start of many new partnerships between Korea and Sweden. Thank you so much.
네, 감사합니다. 스웨덴에 있어서 수소의 중요한 역할과 산업 생태계 그리고 특장점에 대해서 알아볼 수 있었습니다. 다음으로는 스웨덴 에너지청 자자에르 다우디 수석 담당관께서 스웨덴 국가 수소 전략을 수립하는 프로젝트를 이끌었던 경험을 바탕으로 스웨덴에서 수소 개발 그리고 배치에 따른 기회와 과제에 관해 발표해 주시겠습니다. 담당관님을 뜨거운 박수로 함께 무대로 모시겠습니다.
Good morning, everybody here in the room, and good morning, good evening to anyone watching us on the YouTube channel. It's my pleasure to be here in the Sweden Day and explain for you a little bit about opportunities, challenges, and supporting measures for hydrogen in Sweden. My name is Jaza Ardaoudi. I am working at the Swedish Energy Agency, which is a government agency responsible for matters of supply and use of energy, and also mainly focusing now very much on Sweden's transition to sustainable energy systems. So I would like to show you a couple of slides, and hopefully you understand why hydrogen is important for Sweden as background slides. So first of all, our very ambitious energy policy goals, as you see here, no emissions of green. Good. Sorry for this. No emissions of greenhouse gases until 2045. That's one goal. The second one is 70% less emissions from transport sector in 2030 compared to 2010. And then we have 100% renewable electricity production by 2040. So having a look at the total supplied energy in Sweden, what do we see here? Oh, sorry. That's the pointer. A mix of both fossil-free and renewable energy, but also we have quite an amount of fossil energy that has to be replaced. It's decreasing with time, as you see, but it's still there, and we have to replace it with fossil-free energy. It was mentioned earlier by Business Sweden that the electricity in Sweden is clean, and it is indeed almost decarbonized. As you see here, it's produced from mainly hydropower and nuclear power, but also wind energy, which has increased lately during the last 10 years. So if we look at the graph there, you see it was in 2020 reached almost 17% of the total amount of energy for electricity production. So the electricity is clean, but also we have the heating sector is largely decarbonized, as you see. Sorry. They're over. It's only 10% relying on fossil fuels here. So what remains is to curb the emissions from the industry sector, but also the transport sector. In the transport sector, road transport is a major contributor to greenhouse gas emissions, while in the industry sector, we have iron and steel industry that emitting most part of the greenhouse gas emissions, followed by minerals in industries and also the refineries. So fossil-free hydrogen is important for the decarbonization of the energy-intensive industries. It's also very important to increase their competitiveness in the future global low-carbon economy. But hydrogen is also important for the decarbonization of the transport sector, mainly heavy-duty vehicles, long-haul transportation, including trucks, ships, and airplanes. Now I would like to spend a couple of minutes speaking about the national hydrogen strategy in Sweden. Back in 2021, the Swedish government commissioned the Swedish Energy Agency to propose a strategy for hydrogen, electrofuels, and ammonia, and the agency did, and submitted the proposal by the end of 2021. But so far, we don't have the strategy adopted. However, the government assigned the Swedish Energy Agency and some other agencies to implement some measures which are very important for the development of hydrogen. Anyhow, the strategy contains many important parts. One of them is the planning targets, which is to at least have 5 gigawatt electricity capacity by 2030 and additional 10 gigawatts by 2045. So in total, 15 gigawatts electricity capacity to power the electrolyzers. The strategy also highlights the targets for using hydrogen in Sweden, and the most important one is to reduce greenhouse gas emissions, but also to increase the competitiveness of the Swedish companies, increase flexibility and security of supply, as well as export of fossil-free hydrogen products. The strategy also highlights the importance of hydrogen for the different sectors, being the industry sector the one which is most relying on the transition and using hydrogen, and it's actually the industry sector which is driving the development, but hydrogen is also important for the power sector. We know all that hydrogen is identified as a potential mean for balancing the electricity grid, given the growing share in intermittent renewable electricity, mainly wind power. And I mentioned already that hydrogen is important for the transport sector, but it's also important for agriculture and forestry, mainly to producing fertilizers and powering the construction equipment. It is indeed less important for building in Sweden. The strategy also highlighted core barriers and enabling measures to develop the hydrogen economy in Sweden. And the barriers you see to the left, most important is the availability of fossil-free electricity. We do have fossil-free electricity, but it's not enough. We need really to enforce this capacity almost to the double to meet the demand from the industries. The other barriers are similar to other countries' barriers. It's anything from adapt the regulatory framework to have new policies to support hydrogen development, but also increase the acceptance in the society, as well as increase knowledge when we introduce a new energy carrier, and some more technical development and some even more financial support. So what you see to the right, the cube, 4 areas to support the development of hydrogen in Sweden. And these are financial incentives, but also to adapt the regulatory framework, collaboration to develop the value chain, as well as sorry for this. The opportunities are many for Sweden. Some of them already were mentioned by Business Sweden, but I may repeat that most important one is our strong energy policy goals that is really driving the development. But also we have a strong electricity strategy with some measures already in force. We do have, as mentioned, the clean electricity and relatively low prices for electricity. A strong industry sector, which is driving the technology development. That's very important, but also we have the research and academic groups that are very strong, I would say, mostly in material science and system optimization using modeling and simulations, and also a very skilled workforce in Sweden. There are challenges, though, not that many, but still they are there, and we have to solve these issues and reduce the complexities in some of them. And the main challenge here is, of course, the need to do this expanding the electricity system. So it's very extensive expansion, which will cost money and take time, as well as we do have the problem that Sweden is not a gas country, so we lack infrastructure, we lack long-term storage, so we need to solve this. The production cost of hydrogen is still high, and also we do have, to a certain extent, limited in production capacity. Our permits are long and complex, so we need to make them more efficient. My last part in the presentation is about the targeted government support to the industry sector and the transport sector, and I will give you examples of some of them. I will not have time to cover every measure here. So for the transport sector, we have 2 main programs. One is the Industrial Leap, which is a financial support to industries, but also to research, academia. Within this program, they fund research and development projects, as well as pilots and demonstration projects. And it has been quite a lot of amount of money that was granted to hydrogen projects during the last years. The second program, called the Climate Leap, it's quite similar to the Industrial Leap, but with a broader target group. So they provide funding even to municipalities and region and counties, as well as to organizations. So they have funded last year's more than 41 hydrogen projects. For the road transport, there are several programs. One major program is the one called Road Transport Vehicle Strategy, Research and Innovation. Within this program, a lot of projects have received funding for research on engine development or emission from hydrogen engines, as well as demonstration of fuel cell heavy-duty vehicles in real applications. There is a special program for aviation called Fossil Free Flight 2045, similar to the one for road transport. This program funded research projects on in hydrogen engines and emission control from these engines, as well as electrofuels for aviation. Additional program was for maritime, but that was rather limited. And also funding for competence center for hydrogen. There is also 2 programs for hydrogen refueling station. Last year, the government funded 100% capex for the development of these stations. In addition, there is a premium for purchasing fuel cell heavy-duty vehicles. That's about 20% of the purchase price. My last slide here is showing you on the map the hydrogen refueling stations which have received funding from these 2 programs. To the left from the regional electrification pilots, and to the right the one from the Climate Leap. In total about 50 hydrogen refueling stations. Some of them will be in operation this year and the rest in the coming 2 years. That was all what I intended to say. I conclude by saying that hydrogen is going to be one part of the energy mix in Sweden. It's important for the decarbonization of the industry and the transport sector. And Sweden recognizes hydrogen as an energy carrier and would want to use it when it is economically efficient and make most system benefit. Thank you for your attention.
네, 감사합니다, 담당관님. 스웨덴 수소 생태계 내에서 사회 경제적인 발전을 위해 정부의 목표 그리고 지원 프로그램 등을 알 수 있었습니다. 다음 순서로는 스웨덴 이모빌리티 센터 린다 얼롭숀 센터장님께서 스웨덴 이모빌리티 센터의 활동과 주요 연구 분야에서의 전기 이동성 연구 내용 등에 대해서 소개해 주시겠습니다. 센터장님을 박수로 맞이해 주시겠습니다.
Thank you. Very pleased to be here. Good morning. My name is Linda Olofsson. I'm the director of Swedish Electromobility Center. And I will start my presentation by telling you something about the center and what we are doing. So we'll be kind of technology wise, this presentation. And then I will go into what we are doing on fuel cells and the hydrogen application within transport sector. So the Swedish Electromobility Center is a competence center, a national research center for electromobility in Sweden. And we are funded by the Swedish Energy Agency, 1/3, and then 1/3 from the industry and 1/3 from academia. So it's really a triple helix collaboration. And it's a growing center. And it's mirroring actually what's happening within the area of electromobility. So electromobility is seen as a main cornerstone for the transition into fossil-free future and the solution for transport. And so we have grown with a number of partners that you could see in our last slide. And the center has been around since 2007. And we have developed a way of working that's very fruitful between our partners that are actually competitors. But in our center, they are able to collaborate concerning research and share their challenges with both each other and the researchers so that we can find the solutions that bring electromobility forward. And we work with roadmaps and project creation and lots of workshops to bring the area forward. And the backbone of our center are really 5 theme areas. And these are what we see the response to what we need to do within electromobility to make electromobility happen in a full scale. We have three theme areas that's on the system on board the vehicle, and that is intelligent vehicles and systems, where we use mathematical modeling and optimization to optimize the system on board the vehicle. And then the second one is electrical drives and charging, where we look into the electric motor and the charging needed for the vehicle. And then the third one is energy storage, where we have both batteries and fuel cells. So this is where I will talk about later. And then we have two theme areas that's involving the systems surrounding the vehicle. So now we have mature technology on board. We can actually have electric vehicles on our roads, but we need to do things where we have to make the whole value chain for electromobility sustainable. And we also needed users to understand how to use the electric vehicles on a broader scale. So we are looking into that in environment and society theme area. And then we also have to solve how to supply enough energy for an increasing electric fleet. So that's the connection to the electric grid theme area. And each theme area is led by two theme leaders that actually lead a group that work together on how to develop a roadmap for their area and identifying the strategic research areas for that area. Then we use these strategic research areas to fund projects within that area. So it's all a collaboration between academic researchers and the industrial experts. But in order for electromobility to happen, it's important with the system perspective. And how can we achieve that when we have 5 different theme areas? Well, we force them to work together. So we must find a way to get the information from the component level theme areas up to the system level theme areas. And this we do by having cross-thematic workshops and projects, etc., and discussions within the management team, which is actually all of the theme leaders. And and likewise, the information must not just flow in from the left to the right, but also from the right to the left. So we have the constraints from society and from the environment that must go back to the component level. So we don't do sub-optimization. So just to a little bit briefly repeat what Yasser said about hydrogen in Sweden. There are high ambitions, I must say, for hydrogen in Sweden when it comes to the industrial transformation with the green steel, fossil-free steel, I should say, because we do have nuclear power. And then we think that there might be excess production of hydrogen as these local places with industry, and that might actually benefit transport sector. But, however, there is a lack of infrastructure in Sweden. We are not a gas country, so we need to work on pipelines and also fueling stations, but I guess that's something that we have in common with many. We need to work on the standards for that, and etc. And for transport, hydrogen was considered both for the combustion engine, but also for the fuel cells. And within the center, we are working with the fuel cells. So if you look into fuel cells in electromobility, well, I would say in Sweden we have, and maybe in many places around the world, we have this battle of systems for the heavy duty, the long-haul transport sector, where we need to solve because the batteries will be too heavy and time for charging too long. And we have 3 different solutions that we are actually demonstrating in Sweden, all of them, and we have projects within the center. That's fuel cells, That's megawatt charging, fast charging systems, and there's electric roads. So there's a pros and cons with each of these solutions, and so we'll see, but fuel cells is one of the solutions that we are working on. And it might be that all the three of them will actually flourish for a while and will be part in solving specific niche applications. So. And also we are discussing remote construction equipment and aviation, marine applications, not gone that far, but might be a possibility. So now I turn to the research that we do within the center. And that is actually two categories of research projects that we are performing within the center. The first group is on a more fundamental level, chemical level, where we're looking into the cell and the performance of the actual fuel cell. And the second one is how to integrate the fuel cell into the vehicle in a good way to make it work with the rest of the system on board. So I will present first the first group of projects and then the second group of projects to you. Well, there were some animation. I didn't know there were animation here. Actually, sorry. Yeah, so we have this this project that we are working on a 2D model of the fuel cell performance of the gas diffusion layer. And it's a model that we are developing with both theory and experimental measurements to understand the fuel cell. And so far we have developed a model with multiphysics model that actually perform quite well at low and intermediate current densities, as you can see here. And it's both, as I said, measurements of mass transport and electrical properties and mechanical structures and thermal properties, but then also provided, complemented by theory. Yeah, so what I should say is that it seems to agree reasonably well with the experimental data. But however, one must know the transport properties as an exact function of mechanical compression, which is challenging. And also it seems it's highly sensitive to the electrical contact resistance, but I think that's something that we are aware of. And the future work will be try to link the microscopic properties to the pore scale properties of the cell. And also try to understand more about wet and dry diffusivity as a function of the compression and performance at higher densities and optimization of the flow field design for the performance improvement. We are also looking into how we can make the fuel cell perform, the PM fuel cell perform at higher temperatures, which is something we would like because we would like to use less energy for the cooling of the fuel cell. And also there might be some challenging applications, for example, going uphill, etc., where we want to use the battery electricity for other things than cooling. So here we are trying to understand what's going on when we raise the temperature of the fuel cell and what's going on with the pressure, the oxygen pressure, and the relative humidity, and how that affects the performance of the fuel cell. And we see that actually we can optimize the parameters to make it perform in a good way, even at higher temperatures. However, when we force it to age, we can see that it's aging, but it's not as simple as it's dependent on the temperature, but it actually breaks at a higher temperature after a few cycles. Yeah, so now I only have a few minutes left. I will try to go through the system projects that we run. And what I can say is that we are really strong in Sweden with the fundamental level, the material characterization, etc. So the projects that I told you before are areas that we are really strong in. But when it comes to the system and how to integrate in the vehicle, we learned through workshops that this is something we need to improve in Sweden. So we have started a number of projects together with the industry. And also we realized that we also have to have a digital understanding of what's going on, and also a test lab to test what's going on. So the infrastructure, both the digital and the physical infrastructure, is important for the research within this area. And so we performed a number of workshops within the center, and we found that the research topics that we would like to address are balancing of plant, air handling, and hydrogen supply, as you can read here, control, heat management, and reliability. And so we started by developing a digital twin. So this is a model and simulation platform for electrical vehicles, where we included also the fuel cell. And here you can optimize a number of parameters, and you can actually simulate the whole vehicle, what's going on, by changing, for example, characteristics of the fuel cell. And so it's quite advanced, and we keep developing it. And we had it for a benchmark, a challenge benchmark this summer, competition between international teams with a transport mission for a heavy truck, where the teams could deliver good solutions how to perform this mission. And if you'd like to learn more about that competition, I would like to ask you to contact Lars Eriksson. And I think the Swedish team did quite well. I think we came second or something like that. So yeah. And then we actually have two PhD projects where we are working on making this model even better. So here is a project aiming at implementing functions concerning air handling in this digital twin. And now, because my time is running up, I will also say we're implementing thermal management also in the team. So I'd just like to say that thank you for being here, and that we are thankful to the Swedish Energy Agency and all our partners, and also project leaders and experts of the center. So thank you.
네, 감사합니다. 스웨덴 무역투자대표부, 에너지청, 그리고 이모빌리티 센터 담당자분들의 발표로 스웨덴 내에서의 중요한 수소의 역할과 개발에 따른 기회, 그리고 이를 지원하기 위한 다양한 프로그램들에 대해서 잘 알 수 있었습니다. 다음 순서로는 스웨덴의 주요 수소 생산 및 활용 부문의 기업들의 발표가 있겠습니다. 기업들 중 첫 번째 순서로는 알파라발 코리아의 석유화학, 정유, 플랜트, 클린테크 부문 담당이신 신명수 프로께서 수소 생산 분야에서의 알파라발의 가치와 글로벌 레퍼런스를 발표해 주시겠습니다. 박수로 맞이해 주시겠습니다.
안녕하세요. 저는 한국 알파라발에서 산업용 열강기를 담당하고 있는 신명수라고 합니다. 알파라발은 진보된 열 전달 및 분리 기술을 가지고 있는데요. 여기 화면에 알파라발의 기술이 사용되고 있는 여러 청정 에너지 솔루션들을 보여주고 있습니다. 우리는 오늘 이 중에서 알파라발이 집중하고 있는 그린 수소에 대해서만 구체적으로 살펴보는 시간을 갖도록 하겠습니다. 지금 보시는 화면은 알파라발 시각에서 그려본 그린 수소 가치 사슬인데요. 다들 익숙하신 자료이니까 별도의 설명을 생략하도록 하겠습니다. 저는 이제부터 파란색으로 하이라이트된 전기 전해조, 폐열을 활용한 담수화, 수소 디스펜서, 연료 전지까지 판형 열교환기를 활용한 4가지 공정 최적화 아이디어를 소개해드리고자 합니다. 먼저 그린 수소를 생산하는 전해조를 최적화하는 아이디어입니다. 다들 잘 알고 계시는 것과 같이 그린 수소는 물을 전기 분해해서 수소를 생산하는데요. 가장 주요하게 사용되는 전기 분해 기술은 AWE와 PEM입니다. 근래에는 SOEC도 서서히 시장에 주목을 받고 있는데요. 알파라발은 전기 분해 과정에서 발생된 열 에너지를 어떻게 효율적으로 활용할지를 고민해 봤습니다. 전기 분해조는 전기 전해 이후 20에서 한 45% 정도가 45% 정도의 에너지가 폐열의 형태로 방출되는데요. 알파라발은 전기 전해 이후 발생되는 폐열을 재활용하는 아이디어를 제안드리고자 합니다. 일반적인 시스템들은 공정 운영 후 발생하는 폐열들을 시스템 안정화 측면에서 냉각수를 통해서 대기를 방출하는 것이 일반적인 시스템 구성입니다. 유럽 지역에서는 전기 전해 과정 또는 분해된 수소나 산소가 가진 저준위 폐열들을 지역 난방의 열원으로 활용하는 방안을 현실화하고 있습니다. 이는 판형 열경계가 가지고 있는 템퍼러처 어프로치가 최대 1도까지 가능하다는 특징 때문인데요. 저준위 폐열을 온도 손실 없이 재사용 가능하다고도 바꿔 설명드릴 수 있습니다. 국내에서도 몇몇 지자체에서는 이 아이디어를 채택하고 있는데요. 신규 프로젝트가 진행될 때에는 이 시스템을 채택하여서 전체 시스템의 효율을 반드시 높여야 되겠습니다. 다음으로 소개해드릴 그 폐열 활용의 또 다른 아이디어는 해수 담수화 프로세스에 대한 이야기입니다. 아주 개인적으로 가장 흥미롭다고 생각하는 아이디어인데요. 그린 수소를 생산하는 데 있어 핵심 요소 중 하나는 깨끗한 물의 공급입니다. 대부분의 사람들이 물에 대해서는 간단히 얻을 수 있는 자원이라고 생각하실 텐데 전기 전해에 적합한 물을 대용량으로 얻는 것은 생각보다 까다로운 일이 될 수 있습니다. 일반적으로 100메가와트 정도의 전기 전해저에서는 매일 60세제곱미터의 물이 사용된다고 합니다. 유럽에서는 2030년까지 약 80기가와트의 전기 전해조를 설치를 계획 중에 있는데요. 이때 필요한 물의 양을 계산한다면 매일 약 48만 세제곱미터의 깨끗한 물이 요구된다고 계산해 볼 수 있습니다. 이 48만 세제곱미터의 물은 300만 명이 거주하는 LA에서 하루에 소비되는 물과 같은 엄청난 양입니다. 그리고 또 앞서 전기 전해 이후 20에서 40%의 에너지가 폐열의 형태로 방출된다고 했는데요. 80기가와트의 전기 분해조에서 방출되는 폐열을 거칠게 계산해 봐도 16에서 32기가와트의 거대한 에너지가 활용되지 못하고 버려질 위기에 있는 것입니다. 알파라발은 이 두 가지 사실에 연계해서 해수 담수화라는 아이디어를 제안드립니다. 가장 널리 사용되는 PEM 방식의 전해조에서 생성되는 폐열은 약 50도 정도의 온도를 갖고 있는데요. 이 낮은 등급의 폐열은 다른 용도로 사용되기가 쉽지 않습니다. 하지만 이제 놀랍게도 이 저준위 열원은 알파라발에서 공급하는 해수 담수화 장비를 운전하는데 충분한 열원이 됩니다. 담수화 시스템과 전기 분해 시스템을 함께 운영할 경우 약 한 27% 정도의 에너지 효율 증가를 기대할 수 있고 담수 생산과 전기 분해라는 순환 사이클 또한 만들어낼 수 있을 것입니다. 그리고 또 하나, 담수화 장비를 선택하는 데 있어 친환경 인증 여부도 고려해야 되겠는데요. 알파라발에서 공급하는 담수화 장비는 증발 방식이기 때문에 멤브레인 방식의 담수화 장비보다 화학물질의 사용이 매우 적고 이는 오펙스 측면뿐만 아니라 친환경적인 의미를 갖는다고도 설명드릴 수 있습니다. 또 하나 이제 흥미로운 이야기를 드릴 텐데요. 전기 분해조 그리고 담수화 장비의 폐열 활용 사이클은 청수 공급에 한계가 있는 해상 풍력 발전에 주요하게 적용하면 좋겠습니다. 해상 풍력 발전 플랫폼에 담수화 장비와 전기 분해조를 함께 설치한다면 청수 공급에 대한 인프라 구성 없이 그린 수소를 보다 손쉽고 효율적으로 생산해 나갈 수 있을 것입니다. 다음으로는 수소 충전소 하이드로젠 리퓨얼링 스테이션에 적용된 판형 열교환기를 소개해 드리도록 하겠습니다. 우리는 물류 부분에서 화석 연료에서 청정 에너지로의 전환을 목격하고 있는데요. 대형 또는 장거리 운송 수단에서 주요하게 사용될 수소 자동차 분야에서도 판형 열교환기는 중요한 역할을 하고 있습니다. 우리가 HRS라고 부르는 수소 충전기 디스펜서는 수소가스를 고압 350바에서 700바까지 압축해서 수소 자동차에 공급하게 되는데요. 수소 압축 과정에서는 많은 열이 발생하게 되는데 충전 속도를 높이기 위해서는 고온의 수소는 반드시 냉각 후 수소 자동차에 주입돼야 합니다. 이 냉각 과정에서 알파라발의 특수 열교환기가 효율적인 냉각에 도움을 줄 수 있습니다. 수소 쿨러에는 몇 가지 중요한 요구사항이 있습니다. 최대 1000바까지 압력을 견딜 수 있어야 하며 저온의 수소, 약 40도 정도, 마이너스 40도 정도가 되는데요. 이 온도에서도 추상 파괴가 없는 기계적 신뢰성이 반드시 확보돼야 되겠습니다. 그리고 수소 디스펜서의 안에 들어갈 수 있을 정도로 작은 크기라면은 아주 안성맞춤일 것입니다. 현재 시장에서 소개되고 있는 솔루션은 크게 두 가지입니다. 쉘앤 코일 타입과 PCH 타입인데요. 쉘앤 코일은 범용적인 솔루션이지만 열교환 효율이 낮다는 한계를 가지고 있고요. 이 낮은 열교환 효율로 인해서 열교환기가 비대해지고 디스펜서 역시 비대해지는 악순환이 발생합니다. 그러니까 더불어 원재료가 많이 투입되기에 상대적으로 고가라는 단점이 있습니다. 알파라바에서 공급하는 하이블럭은 수소 디스펜서 전용 제품으로 판형 열교환기 기술을 이용하기 때문에 열교환 효율이 매우 높아 컴팩트하게 제작이 가능합니다. 하이블럭은 디스펜서 소형화에 아주 적합한 솔루션이라는 말씀을 바꿔드릴 수 있을 것 같습니다. 잠시 하이블럭 이제 PCH 타입 열교환기인데요. 이 PCH 타입의 열교환기 제조 방식을 잠시 소개해드리고자 합니다. PCH는 Printed Circuit Heat Exchanger의 약자로 전열판을 케미컬 엣징 방식으로 유로를 생성한 다음에 여러 장을 적재하고 그것을 디퓨전 본딩을 통해 제품을 생산하게 됩니다. 이를 통해서 최대 1000바 그리고 마이너스 196도까지 운영 가능한 열교환기가 제조될 수 있는 것입니다. 알파라발의 하이블럭은 이미 전 세계 수출 시장에 많이 공급이 돼서 그 효용성을 인증받고 있습니다. 그리고 여기 슬라이드에 준비되지 아닙니다. 예, 다음에 소개드리겠습니다. 여기 마지막 장이 주제가 될 것 같은데요. 수소 연료 전지의 효율성 증대에 대해서도 소개해 보도록 하겠습니다. 모두가 알고 계시듯이 지금까지 우리가 주요하게 사용하고 있는 전기 생산 시스템은 화석 연료를 기반으로 했고 많은 탄소를 배출했습니다. 미래에는 수소 연료 전지를 통해 탄소 배출 없는 청정한 전기를 사용하게 될 것입니다. 수소 연료 전지에서의 효율성 증가는 앞서 전기 분해에서의 아이디어와 매우 동일합니다. 수소 연료 전지 자체의 에너지 효율은 약 한 40에서 60% 정도밖에 되지 않는데요. 폐열 회수를 했을 때 비로소 에너지 효율을 약 한 80%까지 끌어올리는 것이 가능해집니다. 이 슬라이드에서는 여러 수소 연료 전지 방식을 소개를 하고 있는데 이 슬라이드에서는 앞에 설명드렸던 거랑 주목되는 내용이기 때문에 특별히 설명드릴 거는 많지는 않지만은 수소 연료 전지의 운전 온도가 전기 전해조보다 높기 때문에 폐열의 활용도가 보다 높음을 저희가 소개하고자 이 슬라이드를 집어넣었습니다. 그리고 또 하나 덧붙이면은 현재 시점에서 수소의 생산 단가는 전통적인 기술보다 매우 높다고 볼 수 있습니다. 높은 단가로 생산된 소중한 수소가 손실 없이 온전히 에너지로 전환돼야만 시장의 경제적 신뢰성을 높일 수 있겠습니다. 이런 요구 때문이라도 폐열 회수는 반드시 필요하다고 다시 한번 강조드려서 말씀드리고 싶습니다. 마지막으로 알파라발에서 2030년 목표로 추진하고 있는 컨셉 제로를 소개해드리면서 제 발표를 마치고자 합니다. 컨셉 제로는 제철 산업에서 화석 연료를 사용하지 않고 수소 환원 제철로 생산된 열교환기를 공급하는 프로젝트입니다. 알파라발이 수소 경제 선순환을 만들어가는 선구자적 역할을 하고 있음을 보여드리면서 제 발표를 마치도록 하겠습니다. 긴 시간 들어주셔서 감사드립니다.
네, 감사합니다. 전 수소 밸류 체인에서의 알파라발 솔루션 적용 사례 및 방안에 대해서 잘 알 수 있었습니다. 다음은 셀임팩트 헨릭 잭맨 수석 어플리케이션 엔지니어께서 셀임팩트 포밍을 통한 양극성 플레이트 생산 확대 방안 관련해서 발표해 주시겠습니다. 뜨거운 박수 부탁드립니다.
Thank you for giving me the opportunity to present Cell Impact and how we can help scaling up bipolar plate production with our forming technology that we call Cell Impact Forming. So first, some quick facts about Cell Impact as a company. We are a producer and manufacturer of flow plates for fuel cells and electrolyzer applications. We were founded in 1999. So we are a quite young company still, and we were started in Karlskoga, Sweden, which is somewhere in the middle between the capitals of Norway and Sweden. And in Karlskoga, we have a 6,000 square meter production facility today, where we manufacture and produce plates that we are supplying to customers in Europe, China, Japan, and North America. Sorry, thank you. And today we are a little more than 100 employees in Karlskoga. The key patents for our forming technologies, we hold them until 2035. The markets that we deliver our plates to are for fuel cells and electrolyzers, and the technologies that we are looking at is for PEM, which is low temperature, and also for solid oxide fuel cells. And we are also looking at electrolysis, where we are looking at PEM electrolysis, solid oxide electrolysis, and AEM electrolysis. And we think that our technology is well suited and will have very good quality to produce plates for these technologies. And what I'm here to talk about is the scalability and how we can scale up the manufacturing of these plates. And the problem to be solved is the scaling up. Today, or what is evident here at H2Meet, is that hydrogen, the generation and the usage of hydrogen needs to be scaled up to be able to manage the green transition. And for this to be possible, a lot of flow plates for electrolysis and fuel cells will be needed in the near future. So we need more than, or soon, billions of bipolar plates will be needed for electrolyzers and fuel cells. And it's very difficult and expensive to scale up these technologies with existing technologies that we have today. And this is because the flow plates requires very fine tolerances, very large forces, and short cycle times. They also require extensive cleanliness requirements. And the conventional solution to this is these large and expensive progressive presses that you see here in the image. As you can see, they are quite large. They also require a big foundation below floor level that needs to be accommodated in your factory. So in order to have these in your factory, you basically need to build a completely new factory to accommodate for these presses. The forming is made with lubrication, which then needs to be cleaned after you have formed the plate, and this is an extensive and energy. It requires quite a lot of energy to do this cleaning of the plates after they have been done. And the solution that we have to this, we call this cell impact forming. This forming technology, coupled with the downstream process that we have for this process, is scalable. Since it's cost efficient, we are able to have a short cycle time at around 1 second for this small forming unit. We also form without lubrication, so we don't need to remove the lubrication with the extensive cleaning process. And this gives us a low water and energy consumption in the manufacturing process. One important aspect is also that you can put this small piece of equipment on a standard industrial floor as it stands on dampers, so we don't need this large foundation that you need for the large progressive presses. And our philosophy at Cell Impact is that each production process should be tailored to ensure high quality and lifetime, and this is why we split up the forming of the plates and the cutting of the plates to really increase the quality and the lifetime of the tools and also the plates that we deliver. So here are some more facts about Cell Impact forming. It's a high velocity forming technology. We say that it's 1,000 times faster than competing technologies, and by 1,000 times faster we mean the speed of the tool. So the speed of the tool when it comes down is around or between 5 to 10 meters per second, whereas conventional technology forms at millimeters per second. So this is why we say that we are 1,000 times faster. We're not using any lubrication, as I mentioned, and the technology is unique. So we say that it's low in complexity, and the low complexity comes from that we have very few moving parts when we do the forming. So it's basically just a tool that is moving, and this reduces the amount of maintenance needed to do the forming, and this lowers the life cycle cost of our complete manufacturing of the plates. We're also able to distribute the energy very evenly on what we are forming, which is important. And this gives us a long tool life compared to competing technologies. Another important aspect, since you need billions of these plates in the near future, is that the technology is scalable. It comes with a low capital investment, so a low capex and also low operational cost, since the technique is quite simple. I have already mentioned that it's low on water and power consumption because we don't need to clean away the lubrication. Another important aspect is that it's very small compared to this guy here. You can see that it measures 1.5 meters times 1.5 meters around the waist, and it's only 3 meters tall. So that's considerably smaller than competing technologies. And you can put it on a standard industrial floor as it stands on dampers. And this added together makes the equipment quick to build and short time to add capacity close to the customer, which will be needed because of the amount of plates needed in the near future. Some important aspect is that we form at high velocities, and this gives us an advantage since when we form at high velocities, we get an increased formability. And this formability or increase in formability comes from a phenomenon called strain rate hardening that locally stiffens the material in high strain rate regions, which then reduces the thinning in these regions. And this is a critical parameter for the flow field cross-section. So it reduces the thinning, which then increases the formability. Another important aspect is that we're able to distribute the forming energy very evenly across the whole flow field that you see here. And you want to have an as uniform depth in this region as possible, and we are able to distribute this very evenly. When we measure our plates, we have a maximum minus minimum depth in this region that is less than 1/100th of a millimeter. So this is the tight tolerances that I'm talking about when I say that the flow plates for fuel cell and electrolyzers requires really fine tolerances. Another thing that an advantage of our technology is the lifetime or the tool lifetime of our tools. So to prove this, we did a test together with the customer where we formed 2 million plates with a smaller test tool. So we ran a tool for 2 million plates. I think it consumed more than 150 kilometers of sheet metal to do this test. And then after the test was made, we evaluated the tools, and the tools didn't show any signs of fatigue, no adhesive wear, no plastic deformation, and the tool was still within tolerances after the test was done. The tool we have in production today that has formed the most amount of plates is 1 million, and it shows the same characteristics as the test tools. We believe that our lifetime is at least 2 million plates. And we attribute this to that we can distribute energy very evenly on what we are forming, and this gives us this long tool life. The materials that we use and are used in PEM fuel cells today are stainless steel, so austenitic stainless steel with the grades 304 and 316. We have also experience and in production titanium, and here we have commercially pure titanium that is grade 1 and grade 2. The thicknesses that we use are 100 microns or 0.10 millimeters, but we have also tried for small test tools thicknesses down to 50 microns and up to 300 microns that can be used for electrolysis applications, and the smaller thicknesses then can be used for more lightweight application. The plates needs to be coated when they go into fuel cell or an electrolyzers, and we have good experience with both pre-coated material and post-coated material. So for the pre-coated material, we have customer feedback that the pre-coating stays more intact in the critical regions needed for the fuel cells compared to competing technologies. For post-coating, we see that the uncoated material that we form have a more uniform surface structure when we do the forming. And this is an advantage when you want to go to post-coating, because you can optimize the post-coating process more narrow to get a better adhesion of the post-coating process. So this is also an advantage of our forming technology. There is more processes needed than only forming to develop or to manufacture bipolar plates. So in order to do this, we have innovated some industry-first downstream processes that we call high-precision punching, laser welding or high-speed laser welding, automated leak testing, and sampled measurements. And we have developed these to ensure a high quality, long lifetime, and short cycle time for all these processes. And high-precision punching, we have developed this for large volume plate production, and we try to have the same philosophy as with the forming unit that I showed earlier. And with that, we have made this press compact and with a high precision, so that we can have a high quality, but also that we can have a compact unit that can stand close to our forming unit. This doesn't require high force, since we're only cutting very thin material. It only requires a couple of tons, I would say. So it can be a press with quite low force. We do this also without lubrication, so it's a dry process, so we don't need to clean. And the cycle time is today below 2 seconds, but we strive to have it down to 1 second when we have developed it a bit more. The burr size, which is the quality of the cut, is less than 10 microns, and this we have kept for more than 200 punches, or for more than 200,000 punches with this tool. We can resharpen these tools more than 10 times, so this would give us a lifetime of at least 2 million also for these tools, which is an important step for or an important factor for our customers, because it's part of the cost. And just as with the cell impact forming unit, you can put it on the standard industrial floor, as it has very, very low forces. So this is also an important aspect from the scalability point of view. We also have laser welding, where we have developed a fully automated system for laser welding, where we fully seal the hydrogen, air, and coolant circuits. With the current design that we have, the weld requires two welding steps, which is why you see two laser welders here. And in both of these steps, you have multiple galvo heads, which is a mirror that deflects the laser beam. And this is to decrease the cycle time. And the cycle time we have for the plates, also, of course, depends on the size of the plate. So for a plate with 400 square centimeter in active area, we have a cycle time of less than 7 seconds. And for a plate of 240 square centimeters, we have a cycle time of less than 5 seconds. And of course, we can tailor the process. If laser welding is not needed, then we can remove this process if only monopolar plates are needed. We have also developed an automated leak testing equipment, which is fully automated and uses helium to detect very tiny leaks. Since we are welding the plates, we need to check that the welds are leak tight. This is a requirement from our customers, so we leak test 100% of the plates that we manufacture today. And helium is used both to detect small leaks, but also to speed up the process in the leak testing. Since we weld the hydrogen, air, and coolant circuits, we need to test all these circuits to make sure that they are leak tight. And the leak test has the capability to test leaks down to 4.8 to the power of -5 millibar liters per second. This probably doesn't tell you that much, but it's a very tiny leak that this can detect. So our customer requirements are much larger leak rates than this. The cycle time for doing this test is between 6 to 12 seconds, depending on how many plates we test at one time. It's also important that we know what we are producing. Therefore, we have invested quite a lot in measurement technology. So we have this machine that you can see in the slide here that is able to measure both with digital optics, chromatic white light sensors, and laser scanners. And with the digital optics, you can look at how the cut holes are related to the formed features. So we can see that the cut holes and the formed features are within tolerance. The chromatic white light sensors can scan the channels to see exactly what the formed channels look like and if this fulfills the requirements of the customer. This is not something that most of our competitors have, and our customer don't really know exactly what kind of plates they receive. So this will be a big advantage for us going forward, to really know what we are manufacturing. And as you can see, the accuracy of these machines is on the micrometer level, so it has very accurate measurements, which will help us with our customers. Also important, when we do projects together with a customer, we want to have a design for manufacturing phase. So we want to, oh, wrong button. Let's see, go back. Here's the laser pointer. So we want to have a design for manufacturing phase at the start of every project. So this starts with the customer sending their design to us. We review the design in terms of manufacturability for all the processes that the plate go through. So we look at the forming. Can all the features in the plate be formed? We look at the cutting. Is it possible to cut it with a good quality, or do we need to make some small tweaks? And also welding and leak testing. And it's important to have this process because most of our customer doesn't really know what kind of geometries that they are able to manufacture. So it's important to keep this in mind, that the geometry that you do or design must be manufacturable to ensure the best quality and the lowest cost. And when we are finished with this process, we go on and design the tools in-house at CellImpact, and then we send them out for manufacturing across Europe, where we have selected tool makers because the tools are really fine tolerances to be able to form these tight tolerances. The tools need to be very fine. And then we go on to cell impact forming, cutting holes in the plates, laser welding, leak testing, and other quality control. And also we have some cleaning processes that we can do on the plates if needed to remove particles that have ended up on the plate. So, in summary, cell impact forming and our other technologies, they are scalable, and we try to make them compact, low in complexity, and cost efficient. We are an innovative company where we have come up with very innovative industry-first downstream process manufacturing technologies. We are up and running now. We are one of Europe's biggest manufacturers of bipolar plates, and deliver plates to Europe, China, Japan, and North America. And we have experience from more than 50 bipolar plate projects, so we have a lot of experience suggesting to our customers that can really help them going forward. And we know what geometries and so that can be manufactured. So I think that was everything from me. So thanks everyone for listening.
네, 감사합니다. 셀 임팩트 포밍의 효율적이고 확장 가능한 제조 기술과 50건이 넘는 프로젝트 사례 관련해서 알 수 있었습니다. 다음은 임팩트 코팅즈 한국 지사의 크리스천 힐그렌 대표께서 성장하는 PEM 전해기 그리고 연료전지 시장에서의 코팅 기술 등에 대해서 발표해 주시겠습니다.
안녕하십니까. Switching to English. So I will talk about delivering coating technology and growing electrolyzer and fuel cell markets. And it will be a bit of a mix between market, commercial, and technology trends and what we are doing. First, just Impact Coatings in brief. We are a Swedish company. We were founded in 1997 as a spin-off from Linköping University. We're still headquartered in Linköping, but lately we have been expanding globally, and now we have offices in US, in Europe, in China, and in Korea. And in China, we have recently also opened a coating service center, so we have operations, and we're planning for expanding and doing this in the US as well in the next year. We were listed on the Nasdaq Stock Exchange in 2004. So we have been around for quite some time now with more than 25 years of experience. We are also growing in our hometown. We are building a new headquarters. We're more than twice the floor space for offices and production facilities to meet the growing demands from the market. This will be ready by well, in 1 year, you could say, after in September sometime 2024, we hope to move in. We have been seeing the growing demand in North America, so from the hydrogen industry, especially green hydrogen production, so that's why we are investing in the US. And we're also investing in Sweden and expanding our coating service center there, so we are moving to multi-shift production, we are hiring people, so this is all really going well for us right now. Our new facility in China, in Shanghai, the formal inauguration is in about 2 weeks. It's already operational, however, and there we have the capacity to provide coated fuel cell plates. About 1 million plates a year is the initial capacity. So there is a growing increase in China for sure. Impact Coatings is a full-service supplier of PVD coating solutions. We're not just an equipment provider, we're not just a technology provider, we don't just provide coating service, we actually provide all of it. And this is really to be a customer-centric company to support really faster innovation and scalability, which really helps the industry grow. because every hydrogen company has their own unique challenges. Some are asking for very specific technologies, some are having scale-up issues, others are asking for mass manufacturing. So we have seen that we need to be very agile in this way to be able to support the industry in the most flexible way possible. We also have a quite interesting concept called managed services, which we also think is unique, and that is essentially where the customer would buy our equipment, but we would send in our team and operate the machine for a couple of months to help the customers can learn complicated technology. That this will reduce the risk for error and mistakes, increase overall quality of everything that is produced. Another interesting thing with coating services, since we both sell equipment and coating service, it means that we can be a second source. So should a customer buy equipment and they have some dynamic request, change in how much they need to produce, we can help them supply from our coating service center. So, and this is also something that we think is truly unique. Our coating service also helps with prototyping, pre-series and ramp-up as needed. And now we can do this in Sweden, we can do it in China, we will be able to do it in US, and after that, well, we will see where the next investment will be made. This is just very briefly the timeline. We have been working with the hydrogen coating solutions for quite some time. Our first coating equipment inline coater was introduced in 2003. It's a patented structure. And the fuel cell coating research then started in about 2007. The first commercial fuel cell coating was released in 2012. And from there on, we have been growing every year. We opened office in Korea in end of 2020. Lately, we have been also having new business success in the electrolyzer market, which is very interesting. And now to talk a bit about the market trends that we see in fuel cells. Well, we heard about the battle between fuel cells and batteries maybe. Of course, the numbers for fuel cell electric vehicles, they are for sure smaller than batteries, but still we saw a growth of 40% last year, reaching 72 vehicles worldwide. 80% are cars, 10% trucks, 10% are buses. Well, it's dominated by cars, but actually now we're seeing a lot of interest in the heavy duty segment. So we see that the truck segment actually grew by 60% last year. And since we're in Korea, I want to highlight some achievements in Korea. More than 50% of all fuel cell cars worldwide are driven in Korea. So how about that? And you can wonder why is this? I think it's because of a very strong policy from the South Korean government and the industry's ability to follow up on the policy and targets that were made. I think in the 2019 roadmap, the target was about 80,000 fuel cell vehicles, and I think Korea hit about 30,000. So almost 50% of the target was achieved, and regardless, this is an absolutely world leading country in terms of fuel cell passenger cars, no doubt about it. Another interesting fact, we're not that far from China, and actually China has a huge portion of the heavy duty segment. 85% of the fuel cell trucks, 95%, and 85% for the fuel cell buses. So that's an equally impressive number, you could say. And so how do we respond to this? Well, going from the passenger car to the heavy duty segment, you have a different operational pattern. You have much longer durability requirements. They are used in continuous operation. You have less time for refueling or recharging. And all of this adds to the technical requirements for the fuel cell stack, and in the end it puts a lot of requirements on the coating technology. So we're seeing 50,000 hours of fuel cell stack durability, factor of 10 increase, which is of course very challenging for an electrochemical system. So what we've seen also, deeper understanding of the fuel cell degradation mechanism from real-world driving data that was completely inexistent like 5 or 10 years ago. And all of this has really shown that we need a next-generation coating technology to support this development. Well, and electrolyzers and green hydrogen, which has been growing very, very fast in the last couple of years. Urgent need to decarbonize, become sustainable. So to decarbonize industry, there is no alternative. You need green hydrogen. There is no battle between batteries or fuel cells as in for mobility. This is just you need green hydrogen. Otherwise, we're not going to hit our sustainability targets. You can see exponential. Sorry. See if I can go back. Here we go. Here, this is a logarithmic y-axis, shows electrolyzer capacity as a function of year. We are down here right now from 2020 to 2023. We have seen exponential growth in installed electrolyzer capacity. And to hit the net zero emissions target by the IEA, International Energy Agency, it needs to continue to be exponential every year. Otherwise, we're not going to hit the targets. So that's the foundation, what we need to achieve, right? What we use, well, mainly we have alkaline and PEM electrolyzers. Those are the two main technologies that are really commercial on the market. They have the largest fraction of volumes. There are other emerging technologies. We are, of course, monitoring those and seeing how we can support those developments as well. But for now, again, let's look at some regional differences. Alkaline is the kind of original technology, really strong in China, while the PEM is kind of the emerging technology. We believe it will become the leading technology in the future because it has some specific technological advantages, really suitable for renewable electricity also. And this region, well, we see Europe and North America, they are the leading regions here. They lead both technology development as well as manufacturing and upscaling right now. But it's very likely that Asia will pick up. There is a big interest in Korea, in Japan. Australia has a huge potential to produce renewable energy as well. So, I mean, there's no reason not to expect that Asia will be a strong region in the future here as well. And what we see that we need to deliver here, it's mostly actually about time to market right now and time to customer. We should be fast and flexible and agile and just being able to deliver high quality. These are the most important factors right now because these systems, we need low technical risk. Then you have some industry standard solutions right now, and we are able to deliver there. So the challenges here are a bit less on the technical side, but you could say more on the upscaling and commercial side right now, for us at least. And we also have to deal with some novel metals, which I will also talk a bit about. So I will present 3 products now and give some highlights. A next generation premium fuel cell coating to solve the needs for the heavy duty segment. Our electrolyzer coatings for PEM electrolyzer plates as well as porous transport layers, and also our latest coating system, the Inline Coater 2000. Here we go. This is really exciting stuff because we believe this could really be the game changer that will really improve the durability of metal plate fuel cell stacks. Here we have a brand new coating with extreme corrosion resistant. This will handle voltage spikes up to 1.6 volts for more than 10 hours. This means it is reversal tolerant or cell reversal tolerant. Whenever you drive, you have a mobility stack. You want very stable voltage, but real world driving data shows you don't have it. You have spikes occurring for a few seconds, and they are really transient. But the only way to solve this is to have materials that don't degrade. You could have feedback systems and try to manage the system, and surely that will improve the situation, like controlling gas, humidity, and so on. But the question is, are you fast enough? Similar technologies, or concepts, I should say, were also developed for the catalysts, where you have reversal tolerant anodes, for example. We also have really low contact resistance for this one, so it means you get high fuel efficiency. And overall, this high corrosion resistance will also help to protect the membrane and the catalyst, because if you have corrosion from the metal plate, like you can leak chromium ions, nickel, for example, this will have a very bad effect on the catalyst layer. So if we prevent this, we also improve the durability of the membrane. So it's really a positive spiral, you could say, in this case. Electrolyzer coatings, we do gold, platinum, iridium. We do this, we can coat these plates very efficiently, cost-efficient usage of noble metals. We can mask plates, we won't coat the active area. We handle the recycling and everything in refining, so we become really cost competitive, for example, compared to selective electroplating, which has been around for a very long time. With PVD, we can do the coatings thinner, use less noble metal, we can make them denser, we have excellent adhesion. And all of this means that we have a really strong position here and that we are able to deliver not only samples, but we can also deliver commercially at scale. These plates here are used in megawatt scale stacks already today. Coating machine, well, you need a coating machine to produce. We do coating service, we take care of everything. The customer buys the equipment, you eliminate logistics. You have your own machine, you can run 1 shift or 3 shift, you can run it fully automated, you can have a robot integration. Small footprint, modularity, can be used for both fuel cells and electrolyzers, depending on the configuration. Some recent updates, cloud-based data analytics, so being able to see what happens in the coating machine. Traceability, we see that all plates will have laser marking, be QR code tracked, so you can see in 10 years, you can trace back every single plate that was ever coated. So, going back to our complete coating solutions offers, we have really cost-efficient production depending on what the customer needs. Coating service, no investment, scalability, equipment, some investment, sure, but then you can get a lower piece per part in the end. We're flexible, we have scalability. One of these systems could produce millions of plates. If you need twice, you get 2 systems. If you need 20 million plates, no problem, you have a couple more systems. So this really helps the hydrogen industry to grow, we think. Durable performance, we think this is one of the key technical issues that we are addressing and solving, since it's very likely that it is very expensive to replace a degraded stack, fuel cell or electrolyzer in the field. So having a good premium coating that gives the right durability in the first place should give a lower total cost of ownership in the end. So this is really why we think durability is key, and we fix it by solving the corrosion issues in the first place. PVD is also a green, sustainable process. We only use electricity. These are vacuum coating systems, so there is no chemical waste. You don't need any special license to set up operations for this. So it's all very green and sustainable technology in itself. I would like to welcome everyone to our booth after the Swedish Hydrogen Day. Unfortunately, our booth number is CO2, so my special thanks to the organizers for this. And here you can also see some actual fuel cell plates and electrolyzer plates that are coated. So you can see them side by side in our booth. And yeah, well, my contact details, but you know where to find me, CO2, right? Okay, thank you very much.
네, 감사합니다. 임팩트 코팅사의 PVD 코팅 기술에 대해서 잘 알 수 있었습니다. 네, 저희 내일까지 스웨덴 국가관을 CO2 부스에서 운영을 할 예정이니까요. 많은 방문 부탁드립니다. 마지막으로 크래프트 파워콘 라울 몬타노 기술 및 제품 이사께서 수소 설치를 위한 전기 생태계 최적화, 스케일업을 위한 과제와 고려사항 관련해서 발표해 주시겠습니다. 많은 박수 부탁드리겠습니다.
Thank you very much. It's really an honor and really exciting to be here. We have seen how much Sweden has contributed to the green hydrogen revolution, not only from the political arena, also how we are helping and enable the electrolyzers. And now I would like to walk you through the challenges that we foresee to power the green hydrogen. My name is Raul Montano. I'm working for Kraft PowerCom Sweden, and let's walk you from what we see, what is our vision, and what we need to take into account when we're going to be scaling up. Yeah, just a bit of the background, what we have seen. Apologies, there have been some challenges and problems with the funds, but anyway, the important is the message and how the message is delivered. We foresee that globally, at least 12% of the global energy consumption will become from green hydrogen in the future by 2050. That being said, South Korea is expecting to have at least 30% of their energy utilization by 2050. And it's no surprise what Henrik just mentioned, that they're expecting also to use at least 200,000 vehicles powered by fuel cells. So overall, we all know we are in a race against climate change. There is about 120 countries that already had set their goals to try to reverse the global warming. And among those, there is at least 32 countries that have set their goals on green hydrogen productions. So what do we need to do? What do we need to overcome just to really scale up the green hydrogen? Well, definitely we need to make it affordable and reliable. We need to work all together from different perspectives to move forward, not only in production, but also in energy. We can see that one of the major challenges and the major competitors that I wish to call for green hydrogen is not going to be among all the different parties. It's going to be how we can power the green hydrogen industry, from where all this energy that we need to decarbonize the electrical power system can come. So in essence, we are looking on how we could have a better performance from the perspective of the plan, how the overall plan could perform. And that, if you start to dig out, then you have to look into the electrolyzer as itself, how the electrolyzer can be improved, and then naturally, last but not least, how we could improve the use of energy. And when I said use of energy, I wish to make a remark. It's not only the electricity, it's how we use all the different resources that are going to be necessary to build all the equipment that are going to be powering the hydrogen industry. Just for you to have an idea, around 70% of the OPEX is coming from electricity. And among that 70%, if you just look into the CAPEX, 50% of the capital investment is going to the electrical infrastructure that is powering the green hydrogen industry. Here is, I want to take just a kind of an example, what we see scaling up. One of the major challenges or difficulties that we foresee until now is that the green hydrogen experience is in a medium small scale size. And I'm gonna just take an analogy. It's like riding a bicycle alone. When you are having a nice ride, you are yourself outside. It's quite easy, simple, but I don't know if you have tried to be in a double-seated bicycle. Then things start to become more complicated. Now you need to start to coordinate with your partner in your back. Then what happens if you start to have a 5-seated bicycle? Then now you need to really coordinate with all your fellow colleagues just to really start to moving forward. And I'm going to take this later. Imagine that you have now these different 5-seated bicycles, but now you're in a peloton. You're trying to run the Tour of France in a 5-seated bicycle. Things really become complicated. You need to really to start to think, what is the guy in the next side doing that you will not be falling up? So the industry, in principle, is just looking at a very simplistic approach. They're just trying to see that we're going to use building blocks, simple components. It's just a power transformer and then a power supply unit. We have just a 5 megawatt ones, and then we start building up. But just for you to get into the context, what are we talking about? Imagine, just to cope with the goals that Korea and Europe has set for the green hydrogen, we will need at least 6,000 power transformers for each country. And those 6,000 power transformers are going to be competing with the electrification of the urban vehicle. So what you can see is that it's not purely just to have access to the technology, it's also how we can use the technology. And if we just take one step backwards, we need to think on how much iron and copper we need just to build all those 12,000 transformers that are going to be needed. So in that particular sense, that's what we believe. We need to start to think on how we can build up the overall electrical infrastructure that it will be powering the green hydrogen. Yeah. So what it will happen is that, if I take one step backward, we could start having performance problem, as I said. I mean, so far we have been just seeing powering 1 or 2 electrolyzers. Now we're talking about potentially plants that it will have 20 to 50 or 100 electrolyzers working together. We have seen experiences in other countries that they have not been able to be producing at full scale because when they try to run the plant, they start having performance problem. And the grid operator has set limit to be at 50%. And you don't want to have your full plant just standing still, producing 50% of your capacity. So that's what's happened when you start to look into a standard solution versus optimized solution. Because the biggest challenge is how to understand where the problem is coming from. Who is the piece that is underperforming? Then you need also to understand what are the local grid regulations and understanding the needs. I can tell you an example in Europe. There were in the same country 2 different requirements, and one of the pieces that we came across, it was because simply the network was not strong enough to stand the overall performance of the new plant. You need to really start to think on the balance between CAPEX and OPEX. Just for you to have an idea, when you start to look into the energy need, you could run into problems of over-dimensioning. There is a rule of thumb today that if you want to have a 1 megawatt green hydrogen installation, you need to have access to at least 2 megawatt green energy. So if you don't look into carefully these different factors, you're going to be over-dimensioning, and then naturally your project business case will not fly out. Then you need to start to think on the overall economy of the plant. Today, the economy goes into already set sales targets, meaning that we have already sold the productions, but we need to think of hydrogen as an energy carrier, meaning that you could be the backbone of the electrical power system. You could sell either hydrogen, or if you have the capability and the capacity to be in a bidirectional system, you could also sell electricity. So all in all, what we wish is just to try to optimize what you see when you start to designing your plan. Just really look into the overall context of the design of the plant, what are the requirements from the grid, where the plant is going to be located, what kind of technology you're going to be using, and then try to control what you don't see. You want to control the on-plant downtimes, you want to control the efficiency of the plant. Naturally, health and safety is a must, so you will not be running in a supply chain problem. And I can just take an example. Recently, I read an article that it was against the hydrogen technology in Birmingham because Birmingham City had launched a very aggressive bus plan, but they didn't secure the supply chains for hydrogen. So another important issue is the location. We can't just take every project as equal. You need to start to think whether if your project has access to electrical infrastructure. Is it your grid strong enough? Is it a weak grid? You can't take a simple standard solution for each of the problems or the solutions, because otherwise what you're going to be running is an operational challenges. Then what are the requirements that your network and your infrastructure need? How many segments are you going to be dividing your plant? Now we are talking about 100 megawatts. Imagine the impact of removing 100 megawatts from the power grid. That will be a no-no. So you need to really start thinking how you're going to be sectionizing the project, how you're going to be operating the project. If you have only access to 80% of the energy, how can I just optimize the overall plant operation? And is it an isolated process or is it within an industrial process? That's also something important. Do you need redundancy? And more importantly, do you have access to means of filtering or other means that it could save the investment of the project overall? This is something really interesting, and I would like to take a couple of minutes in here. There are two dominant technologies when it comes to powering green hydrogen industry. One is based on thyristor technology, the second one is based on IGBT. Based on different marketing strategies, there have been a lot of speculations around IGBT and thyristor. Some people say IGBT is like the Ferrari today. It's a very refined and new technology. Thyristor is like the old Fiat that is very old, it doesn't work properly. And there is a myth that says that IGBT technology doesn't produce any harmonics. It doesn't produce any distortion to the power network, which is not true. I mean, whoever knows and understands physics and power electronics understand that any switching devices will always create distortion to the network. What you could do is working with the topology of the design of the power supply, you can put ways and means to mitigate the harmonic injection. That could be done with thyristor or IGBT. So in essence, it could be any or it could be both. So depending on the performance of the plants, where your plants is going to be located, what are the requirements of your technology, which kind of technologies you're going to be using. Is it going to be a PEM? Is it going to be an alkaline? Is it going to be an SOEC? Depending on the overall design of the plants is what you could start deciding if in one case could be a thyristor, if it could be an IGBT solution. So, yep. What we want to see, and we are working together, is just trying to move in from a single point of connection, a single branch, to an optimized electrical ecosystem, making sure that all different components are working in alignment, are working together, that every single project have the least impact to the network, because that is what you are going to be looked at. You are going to be putting in requirements that you need to pollute the least that you can, and you can optimize the production of your plant. And with this as well, we are in CO2, and you're more than welcome to come and visit us. We wish to be carbon-free, but unfortunately, that's what the organizers gave us. Thank you.
네, 감사합니다. 수소 생산에 필요한 전력 생태계와 크래프트 파워콘 사만이 가지고 있는 카펙스, 오펙스 절감을 최적화된 기술에 대해서 알 수 있었습니다. 이상으로 오늘 준비한 모든 세미나 발표는 마치도록 하겠습니다. 내빈 여러분들께서는 발표를 들으시고 궁금한 점이 있으셨다면 거수하신 후 편하신 언어로 질의해 주시길 바랍니다. 네. 저 잠시 마이크 좀 네. 그리고 먼저 그 질문 주시기 전에 소속과 성함 말씀해 주시면 좋을 것 같고요.
예, 저 딜로이트 컨설팅의 김기동 상무인데요. 두 분에게 질문을 좀 드리고 싶은데 알파라발에 먼저 질문한 것. 그 해상풍력에 아까 그 수조내용 담수 공급하는 거 혹시 그 실적이 있으신 건지 아니면 그렇게 시스템을 현재 개발 중이셔서 공급하려고 계획 중이신 건지가 제 질문인데 답변이 가능할까요?
네, 제가 설명드린 거는 저희 알파라발이 수전의 시스템을 다루지는 않고요. 담수화 장비를 다루는데 이 장비는 저희에게 새로운 게 아닙니다. 선박에 보통 이 담수화 장비들이 설치가 되게 돼가지고 저희에게는 익숙한 장비이고 현재 설치된 사례가 있는지는 제가 정확하게는 모르겠습니다. 근데 현실 가능한 아이디어라는 거는 말씀드릴 수 있겠습니다.
아직 그러니까 실적에 대해서는 조금 더 본사로부터 들어봐야 되신다는 말씀이신 거죠?
네, 제가 정확하게 그거는 파악을 못했습니다.
예, 알겠습니다. 두 번째 질문 우리 스웨덴 에이전시에서 오신 분인데 아까 대화하다가 발표했는데 지금 모빌리티 쪽에 수소 충전소가 100% 스웨덴 정부에서 지원을 하신다고 아까 말씀하셨고 발표도 그렇게 하셨는데 그러면 모빌리티에서 판매되고 있는 수소는 전부 다 로카본 하이드로젠인지 아니면은 다른 타입의 하이드로젠이 있는 건지가 궁금합니다.
So thank you for the question. If I got it correctly, you are asking about the incentive that the Swedish government has provided to building the hydrogen refueling stations, and you wanted to know if the equipment that we are using in the refueling stations are from anywhere, or was that correct understood?
My question is the hydrogen.
The hydrogen.
Yeah.
Where is the hydrogen coming from?
Yeah.
That was an excellent question. You might imagine now we are just starting to build these refueling stations. So our focus has been really to get rid of this chicken and egg problem. So we invested in Sweden in establishing the refueling stations, and the developer has made some memorandum of understanding of some suppliers of fossil-free hydrogen. But in some cases, they are not ready yet. So some refueling stations are getting hydrogen from nearby, shipped to them by trucks. In the other program, you might notice in my presentation, the Climate Leap, they provided financial support to refueling stations that has electrolyzers on site. The other program didn't, because the other program has higher capacity demand of 2 tons per day of hydrogen. So some of them have secured the supply of hydrogen. Some are waiting for a little bit larger projects for production of hydrogen, and that is going to be delayed a little bit, but hopefully not so much. So far, shipping by trucks. In future, when we build the pipelines or this kind of infrastructure, it will be easier. I hope that I managed to answer your question. But the condition for all these refueling stations is to be run on fossil-free hydrogen.
네, 감사합니다. 다음 질문 하나 정도 더 받을 수 있을 것 같습니다. 혹시 질문 있으신 분 거수 부탁드립니다. 네, 너무 이렇게 명확하게 발표 내용들이 잘 전달되어서 그런 것 같은데요. 저희가 그러면 오늘은 그 스웨덴 수소 생산 및 연료 전지 세미나를 이상으로 마치도록 하겠고요. 저희가 잠시 후 2시부터는 한국 스웨덴 청정 에너지를 위한 라운드 테이블 프로그램이 준비되어 있습니다. 식사하시고 많은 참여 부탁드립니다. 그럼 귀한 시간 2시간 동안 스웨덴과 함께 해주셔서 감사드립니다.